Well, I would just, it was 65 when I got in here. Yeah, so it's on its way. So I think the set point is 72 Fahrenheit. Can you hear me now, Ivan? No, no worries. Give it one more minute and then we'll get going. Okay. I think that's resolved. Okay, good morning, everybody. Good morning, good afternoon, greetings. Thank you for joining us today for our webinar on Biomark's small-scale monitoring system. Biomark has historically provided monitoring systems for large-scale applications like fishways, fish ladders, and in-river applications. But we wanted to develop a solution for to more cost-effectively monitor small-scale scenarios such as ground squirrel burrows and bird nests. The large scale, the difference between the large scale and the small scale is that the large scale systems typically use a single reader, RFID reader, for each antenna, whereas the small scale system that we've developed uses a single reader to control multiple antennas. The systems are currently being used in laboratory environments to monitor multiple enclosures, in the field to monitor individual ground squirrel burrows, and also movement between bat habitats in a laboratory setting. So today's webinar provides an introduction to the hardware and software developed to provide a simple, easy-to-use monitoring system. And as always, if you have any questions, please do not hesitate to contact us. And during the webinar, please feel free to raise your hand or ask a question using the chat box on the right-hand side of the screen. And one of my fantastic assistants, Elsa or Kendall, will pass those questions on to me. So that's a little brief introduction. I'm going to run through the hardware that you can see in the video, and then I will go through the software after that. So the system comes in two configurations. This is a small scale system controls 16 antennas, and the connector ports for the antennas are located on the back of the case. So there are 16 ports, and the ports are identified from 1 to 16, and you cannot change the ID of those ports. And provided with each case is a laminated card that shows the ports of 1 to 16. It would be viewed as though you're looking at the back enclosure. That's how the IDs are laid out. So there's a 16 antenna system and the smaller 8 antenna system. Both enclosures have accept DC power on the back receptacle or DC power on the front. AC power, there's a universal power supply integrated into the unit that accepts 110 to 230 volts AC, and the DC power is 12 to 24 volts DC.
Are the antennas waterproof?
I'll get to that. Yeah, good question. I'll get to that. On the cover plate of the enclosure, there's a three-way position switch that allows you to, where you would select whether it's DC power to turn the unit off or DC power. And then there are also a series of lights that indicate whether the reader is on and operational. Period. And I guess going back to the power, each system includes DC power cables. So the DC plug goes into the receptacle, and alligator clip to go in batteries. These can actually be removed. If you remove that Allen head screw, you can remove this wire. It provides a ring terminal that you can permanently or more permanently fix to a battery. So those are the enclosures, the MUX 16 and the MUX 8. We currently have 3 standard sizes of antennas. There's a 10-inch circular antenna, that's inner diameter, a 10-inch, a 6-inch, and then the 3-inch antenna. And each of the antennas comes with a 50-foot or 15-meter excited cable that is attached to the antenna. These off-the-shelf antennas are not intended to be fully submerged or submerged for an extended period of time, but we can manufacture antennas that do have an open motor connector for continuous submersion of the antenna. But the off-the-shelf ones are not intended. They can certainly get wet, but it isn't something where you would put it in a pond or an aquarium for a long-term monitoring effort. Along with the 3 antennas, we also have 2 what we call extension cables. We have a 20-foot or a 6-meter extension cable, and then a 50-foot or 15-meter extension cable. And these would be connected to the antenna cable on the antenna and then into the reader. And there's no change in performance by adding the length, but depending on, if you're in an outdoor environment and monitoring a number of burrows, we're thinking you might have, or habitats or whatever, you might have situations where you want to monitor something close, and intermediate, and further away, still at a small scale. I guess the other thing I would say is this, the reader is intended to be used as small scale antenna. So maybe we could go a little bit larger than this, 30 centimeters by 30 centimeters, but not to the scale of the antennas that we use with our IS 1001 reader, where we're building antennas that are 6 meters by 2 meters. So this is, small scale applications, multiple antennas, monitoring, again, cages, burrows, tunnels that critters are crawling into. So that's the hardware. So now I'm going to go over, does anyone have any questions related to the hardware?
Is that a little bit hard to hear from a distance? If they have questions, you might need to re-show the.
Okay. Yep.
Better one.
Okay.
Okay. Volume is better now. Perfect.
I guess it's coming from my computer. Are there any questions related to the hardware at this point? Is everybody good? Okay. Okay.
Can it detect avid encrypted tags?
No, it cannot detect avid encrypted tags.
Oh,
That's right. No. Our HPR Lite reader, the handheld reader, can. This it detects full duplex and half duplex, but not the avid encrypted tags. So I'll go over and go to the device manager application. So we developed the device manager application to be the interface with both multiplexing systems. We're finalizing the application and we'll release it next week. That's the plan. It'll be released or available through a download on our webpage, and we'll send all the attendees that link, right? Would you say? And so you'll be able to click on the link and download the application. And as you know, it's a new application and we're adding features or cleaning stuff up. So that does have an automated upload or update function within it, but it certainly wouldn't hurt to every now and again check and make sure that you have the most recent version. And you do that by clicking on the help button and then check for updates. And in fact, I know Andre was working on those last night. Sure enough, there's a newer version.
Before we dive in, we have another question.
Mhm.
I would ask whether the sensitivity of the antennas are similar to HPR plus basic antennas.
Yeah, yes. And I can show that with the I have next to me, I have a 6-inch antenna and a 10-inch antenna. And I would say the read range is comparable to the VP plus antenna.
And then another question was, what's the max cable length?
Right now, the most we've tested is 30 meters is the maximum length of the cable we've tested.
Is it fully submersible in water?
The standard off the shelves are not, the standard off the shelf antennas are not fully submersible in water. But we can manufacture antennas that are fully submersible. It just has to do with the connection and the confidence. The connection on these antennas is more of a compression fit, or not more of a compression fitting. It is a compression fitting, as opposed to the bulkhead fitting that we would use for fully submersible antennas. Hold on, I gotta. So let me go. So that was the update. So am I back on Device Manager? Okay. So simple process of updating the Device Manager application. To connect, so the system itself actually has a Bluetooth or BLE data logger connected or attached to the ASR 650 reader. And to select it, you go to the reader drop down. There's all the other products that we provide, or all the readers. To this one, for the small scale system, is the BLE data logger in the ASR 650. And I guess I'd also note that along with this webinar, we will have a quick start guide or manual that's available, and we'll by next week as well, and that will go through all these same steps. So I've selected the reader, and then to connect to the Bluetooth data logger, I connect or click on the Bluetooth icon in the menu bar, and it'll look for, I guess I need to go look. Geez. I forgot to have also look at it, but on the inside of the cover of the inside cover is the serial number of the data logger that is in that case. In this case, I'm connected to the 16 MUX, and the serial number is 0801. So I'll double click on that. And I guess also while we're at it, I should connect some antennas. Hold on a second. So I'm going to connect to ports 1. And there's a twist that's key. So you just kind of rotate it till you feel it insert a little bit, and then turn the locking collar. And there's the detent a little bit further, and that locks it in. And then I think 16 is down here at the bottom. Same thing, kind of twist it until you feel it go in, and then locking collar, and then it's locked. Power's on. Okay. So then so I've double clicked on the Bluetooth icon. So now I'm connected to the reader. Within Device Manager, there are 2 tabs. There's the Device Manager tab and the Tag Memory Manager tab. The Device Manager tab is where you would adjust the settings of the BLE data logger. And oddly enough, the Tag Memory Manager tab is where you would download tags that have been stored on the data logger. The data logger can store 1 million records, so it's quite, has a quite extended capacity. But if you had a tag or multiple tags in the field continuously, you can and will fill that memory up, especially if you're detecting tags at 32 times a second. So for the software, I'll just go through each of these steps. Each of these expand, and I'll cover the kind of the high level elements of each of the settings. So first, I'm going to go to the BLE data logger setting, and one key feature is the synchronization of the clock. That The BLE data logger is applying the date timestamp to the tag detections, and we're shipping these units around the world. They probably come with a date timestamp that's associated with us here in Boise, Idaho. So when you get the unit, the first thing you want to do, or periodically, is to click the blue bar that sets the date timestamp to the computer that it's connected to. So that's updated. And then some basic features of tag ID display format. There's the option to display the detected tags in decimal, hexadecimal, or numerical. Let me see. Full is here. Let me go 1 second. Let me go over here quick. Okay.
So Steve, as
Yeah.
you're connecting that, there's a question. Is there a manual connection to the reader, or is it only Bluetooth?
It's only Bluetooth. Yep. Yeah, we have the reason for that. The ASR 650 reader has a very extensive list of commands where that really don't need to be seen by us or by the customers. And so we use the Bluetooth data logger as a way to interface with the reader. And we've selected commands associated with the reader that we know users or customers are going to want to adjust. And so the Bluetooth data, going through the Bluetooth data logger, provides a more convenient way to collect data, adjust settings without getting lost in the weeds, we would say. Okay, so if you saw what I did there, I was working on this last night and I was using the 8 muck, so I had to reinitiate that I was using the 16. So going through this again, the tag ID display format, you guys are probably familiar with that. So it's hexadecimal. Oops, I'm in unique. Hold on. So, oh, I get it. So there's a little thing. So I changed the setting, but in order to issue that command, you need to press the green arrows, and then that will change the setting in the reader where it's supposed to. Hold on. I think I've got the wrong inputs. 1 second. Oh, I actually have a sleeve of tags that's sitting next to the antennas. It's probably not very effective. All right, so it's going. So that's the decimal tag code. You can change it to hexadecimal, so alpha letters and numbers, or you can do numeric, which is just decimal without the period. The main, so I'm going to switch this back to decimal. The full record has to do, like, these are full records, and it shows the reader ID, the antenna ID, and the date timestamp. So that's the full, everything that's available. If for some reason you just need the tag code, then you would adjust that to the short, push that to the reader, and now it's just displaying the tag code itself. I can change that back to full. Unique detection unique mode has to do with management of the memory for the most part. When unique is disabled, it'll store every single record that every single detection that occurs. If you enable a delay, let me see. If you enable a delay, it only stores the records to memory as frequent as your delay setting. So in this instance, I have 2 seconds just for the purposes of the webinar. A lot of times for our fishway applications or in-stream, we set that delay to a minute. Small scale stuff it could be different, where it may be, the questions are more behavioral in nature, whereas an in-stream application, we just need to know the animals there. We're not really interested in how long it's there, and that may vary again in the small scale applications. So it's only storing the tag. It'll continue to detect it, but only writes it to memory every 2 seconds in this instance. And then I guess another firmware update. So the BLE data logger has firmware in it as well. And to update that, you would press the update button, and then it'll automatically go to the web and grab the new file to update the firmware. I'm not going to do that now. Any questions on the BLE setting?
Not the BLE, somebody did ask for price, trying to get a quote from the website.
Okay, so the standard price for the 16 unit, the 16 mux, and it's just the enclosure and the reader, that's $3,500. The 8 mux is $2,500. The 10-inch antenna is $510. The 6-inch antenna is $500. The 3-inch antenna is $490, and I think the 50-foot extension cable is $172.16 or something like that. But it's basically $3,500 for the mux, the big one, $2,500 for the 8 mux, and then that price is for each individual antenna. And you don't have to buy a full complement of antennas. So if you have an 8 mux system and you only have 4 burrows, you can purchase 4 antennas. You don't need to purchase 8, but each antenna, that is the price of each antenna. You know, $510, $500, or $490. Okay, so moving on to the settings. So those settings, in that instance, or exact example, we were connected to the data logger that's on the reader, and now we're connected directly to the reader itself. And it's important to note that when you're connected to the reader, you've interrupted the storage of you've interrupted sending of tags to the data logger, and that's what this red banner is telling you. So in this mode, or for the webinar, we're going through the setup process, but when you enter in or you start your monitoring phase, you want to make sure that you click on the data logger setting, so now you're writing tags to the data logger. And also you can completely close the application. You don't need to have the application running or be connected to the units when you're conducting your monitoring study, your monitoring effort, if it's a week long or a month or a year. The device manager is purely used for setting up the data logger, setting up the reader, and to retrieve the data. But when the study is occurring, you can shut down device manager, and you just need to make sure the unit is powered. Okay, so back to the ASR 650 settings. The reader ID, if you have multiple readers. We have a scenario where a researcher has 6 readers and 6 pens. They have 1 reader per pen. So you would obviously assign an ID to each reader based on its location. And then that information is provided in the tag telegram. So it was set to 1, and now it's set to 2. I can go back to here, go to 3 and hit set, and now it's 3. So you have the reader ID, the antenna ID, and date timestamp.
I have one question. Can you connect to device manager using an Android device?
Yeah, yes. I think, where did I have that thing? The device manager currently works on PC and Windows forms. So I guess I would need to confirm on the Android. I know that our software developer typically works, or not typically, works in Android, and so there might be the possibility, but I know this one right now is on the PC, but I can confirm that and get back to you. Let's see, so scan and standby are pretty straightforward. Standby doesn't work. Tag detection, FDXB, HDX, or both. In this instance, I'm using there's a PIT tag inside here. It's an APT12 FDXB tag, but it does read both. Scan time, there are 4 settings. Variable, and this can be a little bit confusing. Variable scan time just means that for this system, you're multiplexing all the antenna channels. You're switching from port 1 to port 2 to port 3. You're not operating all the antennas continuously. You're just operating them at one at a time. And the scan time is the duration that it will sample a single channel before moving to another channel. So if it's fixed at 100 milliseconds, it'll be on one channel for 100 milliseconds and then at 20 milliseconds, so 120 milliseconds, and then go to the next channel. And that's the cycle rate for the entire, for all the antennas that are in the active sequence. Variable just means that if it senses that a tag is in the field, it will extend its scan time until it decodes the time or it decodes the tag or it times out. And I think I've asked for guidance in the manual to recommend when those different settings would be useful. So the read range varies by antenna, and we have a brochure where all the read ranges are listed. So they can see, So again, this is an APT12. I'll do, I have a sleeve of all the different tags, and so maybe when I'm done with my spiel, we can go through the different tags, but I have, APT12, half duplex, biotherm 8, 9, 10, 23, all the different tag types. But for an example, and this goes to the next setting or the next topic. So this is an APT12 in pass-through configuration, and it's detecting it there at that distance, which is probably 25 centimeters or so, a good 12 inches of the antenna. I was talking with someone that was interested in monitoring Carolina toads last week, and their concern was detecting the toads as there would be a burrow in the ground, and the toad would pass through the antenna, and probably a 3-inch antenna, but they didn't want to have, they wanted, did I not connect this antenna? Wait a minute. Connected to the wrong port. They wanted to limit the detection to just going through to just the opening of the antenna. So within Device Manager, you can change the read range using the FDX sensitivity if you're using FDXB tags, or HDX sensitivity. So right now I have it at 100% sensitivity, level 4, and we have a good, whatever, 14 inches of read range. If I decrease that and I hit set, that's decreased the read range by quite a bit. So it doesn't even read it in the middle. So I can go back up a little bit, kind of iterative process. So now I'm detecting it again. So you can determine whether, how, this is your max read range, but if you want to restrict that, then you would restrict it by adjusting the sensitivity slider. Set some. So, and again, all the read range information for each of the antennas is provided on the second page of the brochure for the small scale system. And there's two different, when you see the table, there are two different sets of numbers. One's at 50% power, and one is at 100% power. And then within each of those groups, there are two numbers, and the lower number is the detection range in pass-by orientation. So that's when the tag is parallel to the plane of the antenna, I guess, opening. So I'm detecting the tag still all the way out here. And then the larger number is the detection range when you're in pass-through. So pass-through versus pass-by. So this tag is detected all the way out here. You can also adjust the read range by changing the RF power, the voltage. The sensitivity, it's like I would recommend changing the sensitivity. Well, there's two ways, either the sensitivity or the power. The power setting actually can also control how much draw you have. So if you're using batteries, batteries and not solar or not grid power, you'd want to use the RF power level that provides the read range you want, which is kind of nonsensical or obvious. And I guess what I want to say, if you get the performance you need by having the RF power at level 3, then over level 5, that also allows you to extend the runtime of your battery. So you want to use the lowest RF power possible that provides the read range that is acceptable for your study. And if you use too high of a power, then you can also, it'll cause a voltage fault in the system. Background tuning, when the system turns on, it tunes automatically. But there may be some instances so background tuning, it just constantly is tuning, and there are some instances where it may be advantageous to disable the background tuning. So if the environment is, I think it reads faster. If the environment is stable and nothing is really changing, then you can turn the background tuning off. If you're in a dynamic environment, then it would be worthwhile leaving it on. But these antennas are very stable. So in most instances, after the system is up and running, you can probably disable background tuning. But like anything, evaluate the performance, evaluate the read range, and if one setting works better for you, then go ahead and use that setting.
A few questions. Will our existing antennas, will there ever be compatible with the computer?
No.
Okay.
Yeah. So the ASR 650 reader uses antennas that have a lot lower inductance than the standard IS 1001 antennas. So they're simple antennas, but the earlier antennas, the BP Plus, BP Lite, those antennas are not compatible with this reader.
And then another question on the battery life at 100% of 16 antennas, assuming the deep cycle conformal or the 8-inch battery.
Yeah, so the current draw is about 1 amp or 1.5 amps at 12 volts. I did some calculations. So we typically use 115 amp hour batteries. So for our systems to provide at least 5 or 6 days of autonomy, and we run them. What we would do is run two 215 amp hour batteries in series. So run them at 24 volts. The reader will run from 12 to 24 volts. But if you're running, and so you could use a 12 volt battery, but if you use a 12 volt battery, as that draws down to 12, 11, and 10, then the reader will shut off. Whereas if you use a 24 volt battery configuration, in series, then it'll run fine from 24 volts down to 12 volts. And then the size of the battery is really dependent on your particular application. You could use a 9 amp hour battery if you're doing a half day study, and so it's kind of hard for us to provide solid guidance on how long the battery would last, because it's just a matter of how many batteries you have in your battery box. But we do have an Excel spreadsheet that we use to estimate the duty cycle, depending on the size of the battery pack and the current draw that we know. We can estimate how long a battery pack would last, whether you're doing 415 amp hour batteries where 2 are in series, the pairs are in series and they're in parallel, and that provides 15 days or something like that. But that's information that we can provide with you. But in general, I would use a 1 amp continuous draw at 12 volts as an estimate for what your consumption would be. And also it also depends on the type of battery. If you use kind of standard chemistry battery, sealed lead acid or acid gas mat, we typically estimate the duty cycle to the 50% of the battery capacity. If you draw those types of batteries down further, 80% of their capacity, at some point you'll destroy the battery and they'll have to be replaced. Whereas lithium batteries provide you pretty much their full battery capacity to 80%, or full battery output or full voltage output to 80% of the capacity. However, they're quite a bit more expensive. I'm working with a researcher in British Columbia that has to pack their batteries in onto a hillside to monitor movement of some snakes. And so we deployed some lithium batteries, but a single lithium battery is like $1,900 for about a 100 amp hour class battery, where that same battery is $262 for a standard sealed lead acid type battery.
And then I could ask if you can make that spreadsheet available.
Absolutely. Yep.
And then we have another question about the orientation of the antenna on the ground matter. I decide that.
No, it doesn't matter. No. Okay. So ASR 650 settings, and then going to active antennas, which we saw earlier. I still need to figure out why. When you, so right now, I'm guessing I'm not connected to the correct antenna or something. But when you click the box, there's a hesitation and then it refreshes. I don't know why. Hold on a second. Use real-time troubleshooting. That's there. As far as I can tell, I'm connected to port 5. So now I'm on the bottom, on the outside, and on the bottom. So let's see if I get anything on port 5. No. 16's good. All right. Well, I'll have to call customer service and figure out what's going on there. Okay. So again, the box is where you would select the antennas, and it's only going to sample the antennas that are connected and are identified to be sampled. So you could have 16 antennas, but maybe you don't want to sample them all. So it'll only sample the ones that are of interest. You can grab here. Let's do, yeah. I think they all, that's right. Okay. So those are the active antennas. Synchronization, I'm not going to get into at the moment. Synchronization would be in an instance where you had multiple readers in a setting that each, that had multiple antennas, and you want to synchronize their the exciter fields so they don't interfere with each other. It's not synchronization of the internal clock on the data logger. It's synchronizing of the antenna fields. In most instances, this is not, it's not necessary. But if it is relevant, we'll certainly talk to you about it. So there's the synchronization, and then diagnostics provides, the diagnostic will provide you diagnostic information on the reader system. So here I'm a chart that looks at the FDXB signal level. It's kind of like a spectrum analyzer, and you can see the signal. So if it was here, I have a tag in the field, and that's the tag transmitting, but it could also be noise. So there's a quiet environment, and either a tag is in the field or a noisy environment, and you can save this chart. This is really, these will be really useful for help if you do have issues for troubleshooting, where you guys can save the chart and then send it to us to help identify, if there is an issue, what the issue is. Yeah, so this is 16. I think they're just close to each other, because that's picking it up on antenna 5. Okay, so again, kind of a troubleshooting. If you do have issues with read range or something isn't going correctly, this is a chart that you'd want to save and then send this to us. And cancel that. And then finally, the report. It's for the IS-1001, it's similar to a full status report.
The data format is very similar to what you get with the next one.
Yeah, the data format is the same. So it'd be the reader ID, the reader ID, antenna ID, date, timestamp, tag code. Yeah, all that is very similar. And so here's a report, serial number of the ASR 650, reader ID, active antennas, you know, if you kind of similar to the charts, if you had an issue, this is going to be something we request that you send to us, or at least that you navigate to, you know, while you're connected to Device Manager. And then we can say, you know, what is the FDXB level? What's the HDX? And if there is an issue, help identify where that issue might be occurring. I'm going to go ahead. So before we go into the Tag Memory Manager, have go through some different tag sizes. This is an H, just so you can see the difference in read range. This is, and I'll go back to, so I'm going to cancel out of this, go back to the data logger setting, so that red banner goes away, so we know tags are being stored to the data logger. So this is an 8mm tag. Let me see if we're back up. 100% sensitive here. So pass through with an 8.5. Still pretty decent. Pass by in this area. And you can see the tag code is the same. I don't know where that 30.5 came from. That's a, and then this is a biotherm tag. So if it's a similar, I think it's 13mm compared to 12.5mm, like an APT 12. So similar in size, but it reports the temperature. Because I hold on to the tag, it'll warm up and get into the range of the tag. So it's automatically appended to the tag ID or the tag record. So as I pinch it, it's gradually warming. So biotherm tags. Let me go. We'll do back over to here. Enable FDX and HDX. Hit the green circles to send the command. And go back to settings. And this is a 12mm. 12mm half-duplex tag as well. So the 982. So all the tags. So pass through is always going to be greater read range than pass by, just the way the windings of the tag interact with the lines of flux on the antenna. And it's the same. So this is a wood table. We don't have anything underneath it. So now the burrow's in the ground, the critter's in the ground, but I'm reading it through the table without issue. Or I wish I could get that one work, or if you're on a pipe, 4-inch pipe, and the animal's crawling or flying through, that it would work in that scenario for that configuration as well. Let me see. All right, so that's everything within the Device Manager tab. Let me put my tags away so we don't lose them here. And then switching over to the Tag Memory Manager. Let me move my cord. So to download tags, you simply press the Download Tags button. Duplicate tag IDs would give you every single record. The download test tag IDs, that's actually an artifact from the AS1001, and I'll have that option removed so that won't show up when you're connected to an ASR 650. Start download. Here's the progress down there. So downloaded 201 tags, 197 were duplicates. Say okay. So here's your table of tag IDs. So the scan time, yeah, so this is when so scan date and scan time, that's when the tag was detected. Download date and download time, that's when I just downloaded the tag. So they all have the same record. So what's probably most of value would be the scan date and scan time. So then reader ID, antenna ID, tags are displayed in both hex or DES format. And I think down here, all these tags up on the top weren't temperature tags, so we should have temperature for that biotherm tag that I just scanned as well. So now the tags are in memory. You can, within the Tag Memory Manager, you can export to Excel, to Access, or to a text file. I'm not going to do that. Well, let's see how long. Oh, I'm going to go to the desktop. Let's see. Yep. Hold on. I got ahead of myself. Here's a text file. And there's tag codes. Can you guys still see that? Oh, you are? Okay. Oh. Okay. And then there's the tag codes. And then let's go back to Device Manager. So that's the text file, the tags. So now I've stored the tags, I've downloaded the tags, I've exported the tags, I've verified that the exported tags are there in whatever format, whether it's Excel, access, or text, and then erase the logger memory. Click the erase logger memory. Yes. And now it's erased, and you can see the progress here. It takes so again, the data logger can store 1 million records. I don't have 1 million records, but if you click back on the data logger setting, you can see the progress there as well. So while that's going, that is the end of the information that we have for you today. Are there any additional questions that I can address? Okay.
If we set an interval for storing data to 2 seconds like here, is this maintained when disconnected from the device?
Yeah, that'll be stored. I had that 2 second save yesterday when I was playing around with it, and that setting is saved within the device, within Device Manager. And it's actually the setting of the data logger. So so yeah, when you disconnect from Device Manager, that setting is actually a setting of the BLE data logger that's in the system.
And then I'm not sure if you'll notice off the top of your head, but what would be the extra charge for making the connectors waterproof?
I forget. We did it for somebody for Armando in Italy. It's probably like $100. It's an overmolded connector. So it's an overmolded connector on the antenna, and then also an overmolded connector on the cable itself. But we can provide that for you.
And then how many times a second, like, do antennas report tags?
If an individual antenna can store a tag, well, this is a little bit different than 32 times a second. So if you had, so if I disable this, it's a lot. I mean, so this is a tag in the field continuously. So if you look at a second, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 times a second is for an individual tag. And so if you had 2 antennas, it would be 4.5 or 4 times per antenna.
When local memory is full, does the reader start rewriting?
I believe the data logger has a ring memory, so it's first in, first out. So you would, and I can find out what the chunk is, because it might delete. If it has 1 million records, it might delete the oldest 100,000 or something like that. That's a pretty large memory. We had an older unit could store 5,300 tag codes, and it would delete 250 records at a time on the first in, first out. But I'll verify that.
Can I request to repeat the question before?
Okay.
Can you discuss tag blocking, where 2 or more tags are in the field? It seems the loader that only the closest tag is read in those cases.
Yeah, so it's so the question is about tag collision, And yeah, let me dig out two tags, two loose APT 12 tags. So the tags, it's kind of a, let me go back to here. So I've been at Biomark for a while, I think 18 and a half years. And I used to think that the tag code was being communicated in a, 3D9 or 3DD or whatever tag code, but it's not. The tag code is actually an electronic signal that's being interpreted by the receiver, and then the zeros and ones are converted to a tag ID. So this is one tag in the field. And so if I have one tag, and then I have another tag in the field and it has a similar amplitude, the receiver cannot, so I have these two tags, the receiver can't discern between these two signals. But if one tag moves further away, now the amplitude of this tag signal is stronger and you'll detect it. We have the theoretical discussion we have is if you have two tags that are passing through an antenna, and this tag will be detected. I need a little more separation. And then as they continue to pass, they will collide with each other and you won't detect either tag. And so they'll continue across. They'll probably collide again. And then and eventually this tag will have left the field and you'll get that tag. So tag collision is certainly real. And that might be an instance where you would want to, if you are going into a burrow or through a tunnel, you want to limit the detection range to something that is just within the opening of the antenna to reduce the likelihood of detection. I mean, we build, 80 or 20 meter by 2 meter antennas, and they're great to cover a large area, but also the likelihood of tag collision goes up depending on the numbers of tags that are released. So it's great to have read range, but certainly take that into consideration, and you may want to restrict read range where you have a lot of animals present.
That was a great answer.
Okay, good. Okay. Well, it looks like we're just about out of time. Thank you very much. Again, thank you very much for attending. If you have any questions, please feel free to contact me or anyone else at Biomark. I believe this webinar it is recorded and it'll be posted on our webpage. And then also look for the link for Device Manager, and then we will provide the brochure for the small scale monitoring system as well. So thank you very much.
We did have, sorry, one final question.
Okay, go ahead.
What about changing offset or zoom settings?
Yeah, that was I was playing around with that last night, or the last couple of days. That allows you, so it's kind of, if you want to get into the weeds, I go to the ASR, let me cancel that, ASR 650 settings, and I change that to 100. The ASR 650 always inserts a 20 millisecond HDX, or it's almost a pause, and that is a function to allow synchronization of antennas, so that's always there. But if you do, so I've selected 120, I go to diagnostics, I look at the chart, like a spectrum analyzer chart, and if I change this, so remember, so I have a 100 millisecond scan and a 20 millisecond pause with the HDX. So if I adjust that, so here's one full cycle, and then I think I can change the offset to push it. It's like an oscilloscope. If I go to 0, yeah, so it's 0. So now the beginning of that 100, or actually the 20, it looks like the 20 millisecond cycle is right here. So here are two cycles. So this is 100 milliseconds, and then a 20 millisecond pause, and then the next cycle is 100 and then that's the beginning of the next cycle. And when you synchronize, this is really kind of what you're synchronizing, is this spike to, where if it was just FDXB and you didn't have the 20 millisecond pause like an IS-1001 that's just an FDXB, it's just a straight line. when you have half duplex, or in this instance is 20 millisecond pause, you need to synchronize readers, because what you're really doing is synchronizing this turn on spike. So they occur at the same time, and not have the turn on spike of some other antenna happen right in the middle of the listening period for FDXP. So, okay. Again, any other questions, please don't hesitate to ask. Thanks again. Have a great day, evening, and be safe. Thanks.